Good morning, students. Chapter 6, Work, Energy and Power. In last lecture we have discussed about collision. Yes, elastic collision in which kinetic energy is conserved. And yes, first case, that is elastic collision in one dimension. Okay, yes, we have considered two objects having masses m1 and m2. Before collision their speeds u1 and u2, and after collision their speeds v1 and v2. And yes, we have obtained equations of v1 and v2. These are two equations of v1 and v2. Yes, you have to remember these two equations. Okay, now we will discuss today some special cases for this elastic collision in one dimension. First case, if m1 is equal to m2 is equal to m, means both objects having same mass, then what happens? See, v1 is equal to, here it is 2m upon m1 plus m2, means it is 2m u2, clear about this, plus m1 minus m2 means m minus m upon 2m, here it is u1. So m minus m, so this whole term will become 0. It is 2m upon 2m, cut. So v1 is equal to, it is u2 plus 0 is equal to only u2. Simple. Okay. What about v2? See, in equation of v2 is equal to, in this equation, here it is 2 m1 u1. So I can write this 2 m u1 upon m1 plus m2 means it is 2m. Okay, then minus m1 minus m2 means m minus m upon here it is 2m u2. Simple. You have to replace this m1 and m2 by m, because if their masses are same, then again this term will become 0. Here it is 2m cut. So v2 is equal to, it is u1 minus 0 is equal to u1. So see, it is very simple. v1 is equal to u2 and v2 is equal to u1, means in such collision their velocities are interchanged. Clear about this? Okay, their velocities are interchanged. So yes, it is one most IMP result. Okay, because you will have some MCQs based on this special case. If we have two objects having same mass, and they collide in one dimension, elastically, then after collision their velocities are interchanged. Clear about this? Okay, for example, before collision, this object A and it is object B, its velocity is 5 meter per second and its velocity is 10 meter per second. Then after collision, their velocities interchange, means velocity of A will become 10 meter per second and velocity of B will become 5 meter per second. Clear about this? Yes, it is u1. So u1 is equal to v2. And yes, it is u2 is equal to v1 is equal to u2. Simple. So yes, it is first special case. If their velocities interchange, Clear about this? So yes, it is first result. Second special case. If m2 is very greater than m1, yes, it is m1 and it is m2, if you remember from last lecture. Okay, if m2 is very greater than m1, then what you have to do? Yes, if m2 is very greater than m1, you have to ignore m with respect to m2. You have to ignore m1 with respect to m2. Chalo. In equation of v2, what happens? In equation of v2 is equal to, what happens? Here it is. Here you have to put this M1, this M1. See, here we have considered M2 is very greater than M1. V1, that is speed of first particle after collision. V1, it is speed of first object after collision, and V2 is of second. And V2 is of second. Then how to do? If M2 is very greater than M1, means this particle is very large and this particle is very small. Then if M2 is very greater than M1, you have to take M1 0. You have to take M1 0. Clear about this? You have to take M1 0. Then what happens? See here. Then what happens? See here. In this equation of V1, if you take M1 is equal to 0, then what happens? See carefully. Here it is 2 M2 upon 0 plus M2 U2. Okay, plus M1 you have to put 0 minus M2 upon 0 plus M2 U1. Clear about this? So see, V1 is equal to, it is M2 upon M2, so it is cut, so it is 2 U2. And here M2 upon M1 cut, so it is minus U1. Clear about this? It is 2U2 minus U1. It is 2U2 minus U1. You see? Easy? Yes. So it is speed of first particle after collision. Why? For what is V2? For V2. So see, for V2 what happens? Here M1 you have to put 0. M1 you have to put 0. M1 you have to put 0. So here it is 2 0 U1 upon 0 plus M2 minus M1 you have to put 0. So yes, here it is 0 minus M2 upon 0 plus M2, and here it is U2. And here it is U2. Then what happens? V2 is equal to 0. Minus will become plus, and M2 upon M2 it will be 1. So it is minus plus. So here it will be nearly U2. So V2 is equal to U2. So what is meaning of this? What is meaning of this? If object 1 having mass M1 and another object having mass M2, okay, if this object collides with this object, yes, it is light object and it is heavy object, then speed of this object before and after collision remains almost same. Speed of this object, speed of heavy object before and collision almost remains same. V2 is equal to U2. V2 is equal to U2. If cycle collides with truck, then there is no change in speed or velocity of truck. Okay, velocity or speed of this cycle will change. Clear about this? So yes, in last lecture we have derived these two equations, and yes, you have to think about these two special cases. Clear about this? Now it is all about elastic collision in one dimension. Now we will discuss elastic collision in two dimension. For that, we are taking one situation. See, for example, it is x-axis. Okay, it is y-axis. Clear about this? Okay. Let it is one object having mass m1 is moving in this direction with speed u1. Simple. Object having mass m1 is moving with speed u1. Clear about this? Okay. Another object having mass m2 is at rest. For example, is at rest. Okay, yes. This object is moving with speed u1 in this direction. Obviously, this m2 is at rest, so it will collide with it. After collision, yes, elastic collision in two dimension. After collision, if you know game of billiard balls, okay, what happens whenever there is one stationary ball, and if you push the striker, then what happens? It will move in a plane. They will move in a plane. Yes or no? So I am assuming after collision, this situation is before collision. This situation is before collision. Okay. After collision, I am assuming after collision, I am assuming this first sphere having mass m1 is moving with speed v1, with velocity v1 in this direction, making some angle theta1, with x-axis. I have assumed. Okay, let after collision, this first sphere is moving with velocity v1 at angle theta1 with respect to x-axis, and this another object having mass m2 is moving with velocity v2 at angle theta2 as shown in figure. Clear about this? This situation is before collision. This situation is after collision. Clear about this? So yes, it is one situation that I have assumed initially. Again, I have one object having mass m1, it is moving with speed u1 in this direction. Another object having mass m2, it is at rest, it is before situation. After collision, these two blocks, they are moving with speeds v1 and v2 at angle theta1 and theta2. Clear about this? So now we have to make some relations here. As it is elastic collision, one statement is very clear. Okay, according to law of conservation of kinetic energy. Simple. Total kinetic energy before collision is equal to total kinetic energy after collision. What is total kinetic energy before collision? Before collision, m1 object is moving with speed u1, so it is half m1 u1 square, plus this object m2, it is at rest, so its kinetic energy is 0. Simple. For this, it is total kinetic energy is equal to after collision, yes, this object having mass m1 is moving with velocity v1, so its kinetic energy is half m1 v1 square, plus this object having mass m2 is moving with velocity v2, so it is half m2 v2 square. It is equation number 1. Simple. Kinetic energy, law of conservation of kinetic energy. Now, second, law of conservation of momentum according to law of conservation of momentum. How to write law of conservation of momentum? See, in last lecture, we have discussed about elastic collision in one dimension. One dimension means u1, u2, v1, v2. They all are in same direction. So we have not used vector notation. Yes or no? We have not used vector notation. But in this case, as it is in two dimension, we have to use vector notation. How? m1, yes. Momentum is vector quantity, and how to write? See, here it is. Total initial momentum means before collision, m1 u1. So here I can write m1 u1 plus it is at rest, so its momentum is 0 is equal to this object is moving with velocity v1, so it is m1 v1 plus this object is moving with velocity v2, so it is m2 v2. Clear about this? So yes, first of all, it is vector relation. Now, I will take their components. X and Y components. See, I am assuming it is X direction and it is Y direction. Yes or no? Yes, I have to assume. Then see, this U1, it is in X direction. Yes, it is in X direction. But is V1 and V2 in X direction? No, they are in plane. So we have to resolve this V1 and V2. we have to resolve this V1 and V2. See how to resolve. I can resolve this V1 and V2 like this. I can resolve this V1 and V2 like this. See, V1, it is in this direction. So its two components I can draw like this. One here in horizontal direction and one here in this vertical direction. Clear about this? Yes, it is V1. This angle is theta 1, so obviously this angle is theta 1. So V1 is making angle theta 1 with this component, so it is V1 cos theta 1. Here it is V1 sin theta 1. Simple. Clear about this? Now for this V2, yes, again two components, one in horizontal direction and another in this vertical plane. Again, if this angle is theta 2, this angle is also theta 2. So yes, this component becomes V2 cos theta 2, this component becomes V2 sin theta 2. Clear about this? Clear about this? Yes or no? Hello? If you draw this component here or here, it is same. If you draw this component here or here, it is same. Clear about this? Okay. So yes, we have resolved V1 and V2 into components. We have resolved V1 and V2 into components. Now, how to write? See, first of all, I will write x component of this equation. X component of this equation. X component of this equation. See, it is simple. M1 scalar, so it is M1. U1, it is moving in x direction. It is moving in x direction. This speed U1 is in x direction. So yes, I have to write directly it is U1. Simple. Clear about this? This object, it has rest, so it is 0, is equal to M1. What is x component of V1? What is x component of V1? Here it is V1 cos theta 1. Here it is V1 cos theta 1. And see, it is in this direction. And see, it is in this direction. So yes, here it is M1 V1 cos theta 1. Clear about this? Now, plus M2. V2, what is x component of V2? Here it is V2 cos theta 2. And see, here it is this V2 cos theta 2. It is also in this direction. V1 cos theta 1 and V2 cos theta 2, they are in same direction. So here it is M2 V2 cos theta 2. So here I have plus sign for them. Here I have plus sign for them. Clear about this? Clear about this? Simple. Okay, you have to take x component of this equation. Now y component of equation. See, now y component of equation. See, y component equation. This object M1 is moving in x direction. This object M1 is moving in x direction. So its y component is obviously 0. Its y component is obviously 0. Plus 0 is equal to. Now, see, take care about this. M1 V1. What is y component of V1? It is V1 sin theta 1 upward. It is V1 sin theta 1 upward. So it is V1 sin theta 1. But see, plus M2 V2. This V2, its y component is in vertically downward direction. See, this V1 sin theta 1 is in upward direction. This V2 sin theta 2 is in downward direction. So yes, I have to consider its sign negative. I have to consider its sign negative. So here I have to write minus M2 V2 sin theta 2. Clear about this? Again, it is law of conservation of momentum. M1 U1 plus 0 is equal to M1 V1 plus M2 V2. Its x component. Its x component. Here see right hand side. Both x component are in same direction, but y components, they are in opposite direction. So here it is plus sign and here it is minus sign. Yes, you have to form these three equations. And if you are given any question for elastic collision in two dimension, from this equation number 1, 2 and 3, you can solve any questions. You can solve any questions. Clear about this? So yes, it is elastic collision in two dimension. You have to remember this figure and these equations Okay. Now next, we will see one question, and yes, it is one type of theory. We have to make one result. A particle of mass m1 moving with velocity v1 collides elastically with another particle of mass m at rest. If v1 dash and v2 dash are the velocities of particle after collision, show that these velocities are perpendicular to each other. Yes, we have to make one result, common result. How? See, here it is. What is given? A particle of mass m1. A particle of mass m1 is moving with velocity v1. Collides elastically into dimension with another particle of mass m. Another particle of mass m means they have the same mass. Okay, they have same mass. Particle of mass m moving with velocity v1 collides elastically into dimension with another particle of mass m at rest. It is another particle at rest. Okay, at rest. Okay. If v1 dash and v2 dash are velocities of particle after collision, v1 dash after collision and v2 dash after collision, the velocities are v1 dash and v2 dash. Okay, then show that these velocities are perpendicular to each other. Means if angle between them is theta, if angle between these two velocities v1 dash and v2 dash is theta, we have to prove that this theta is equal to 90. We have to prove that this theta is equal to 90. Clear about this? How to prove this? How to prove this? First of all, we will apply law of conservation of kinetic energy. According to law of conservation of kinetic energy. According to law of conservation of kinetic energy. Simple. Total kinetic energy before collision is equal to total kinetic energy after collision. See, total kinetic energy before collision, m, velocity is v1, so it is half m v1 square. Simple. This object is at rest, so it is plus 0. So yes, it is total kinetic total kinetic energy before collision, and this situation is after. Okay, so after this object having mass m is moving with velocity v1 dash, so it is half m v1 dash square plus half m v2 dash square. Clear about this? Simple? Yes. So it is according to law of conservation of kinetic energy. See, half m common and it will cancel out. So here we will have only v1 square is equal to v1 dash square plus v2 dash square. Equation number 1. Clear about this? This equation is according to law of conservation of kinetic energy. This equation is according to law of conservation of kinetic energy. Now, second, yes, obviously we have to use law of conservation of momentum. Law of conservation of momentum. See what happens. Here it is. What is total initial momentum before collision? This object having mass m is moving with velocity v1, so it is m v1 plus this object is at rest, so is equal to 0. Is equal to, after collision, this object having mass m is moving with velocity v1 dash, so it is m v1 dash plus this object having mass m velocity v2 dash, so it is m v2 dash. Simple. Clear about this? Again, this m cut. So we will have v1 is equal to v1 dash plus v2 dash. Clear about this? It is equation number 2. Now I will take dot product of equation 2 with equation 2. It means, see here it is v1 dot v1 is equal to this equation. v1, what is value of v1? v1 dash plus v2 dash dot v1 dash plus v2 dash. Clear about this? See, v1 dot v1 is equal to right hand side v1 dash plus v2 dash dot v1 dash plus v2 dash. Clear about this? Hello, clear about this? Yes. Now we have to simplify this. Now we have to simplify this. See, v1 dot v1, v1 dot v1, v1 and v1. We have two vectors. They both vectors are same and they are in same direction. They are in same direction. v1 and v1 because they are in same direction. So how to write? Yes. What is a dot b? A dot b is equal to AB cos theta. What is A dot b? A dot b is equal to AB cos theta, where theta is angle between A and B. Then how to write this? This V1 cos 0. Why 0? Because they are same vectors. Okay. Is equal to this side. First of all, we have to simplify. How? V1 dash dot V1 dash. V1 dash dot V1 dash. Okay. Then there is plus sign between. V1 dash dot V2 dash. V1 dash dot V2 dash. Clear about this? So dot product of V1 dash and these two terms. Now of V2 dash. So it is plus V2 dash dot V1 dash. V2 dash dot V1 dash. Now V2 dash dot V2 dash plus V2 dash dot V2 dash. Clear about this? So yes, you have to open bracket. You have to open this bracket. Okay. So now V1 dot V1. What is V1 dot V1? It is V1 cos 0. V1 cos 0. Now I can write this term as, see, V1 cos 0. Cos 0 is 1, so it is V1 square. It is V1 square is equal to this side V1 dash dot V1 dash. So yes, if V1 dot V1 is equal to V1 square, I can write V1 dash dot V1 dash is equal to it is V dash square. Yes or no? Is equal to it is V1 dash square. Plus, now see this term, V1 dash dot V2 dash plus V2 dash dot V1 dash. But we know that A dot B is equal to B dot A. A dot B is equal to B dot A. So how to write these two terms? I can write these two terms as it is plus 2 V1 dash dot V2 dash. Clear about this? Plus last term is V2 dash dot V2 dash. What is V2 dash dot V2 dash? It is plus V2 dash square. It is plus V2 dash square. Clear about this? Okay, so yes, it is simple. Now how to write? See here carefully. Okay, I can write this term as V1 square is equal to, it is V1 dash square plus this term V2 dash square plus 2 here V1 dash V2 dash cos theta. What is angle between V1 dash and V2 dash? What is angle between V1 dash and V2 dash? It is theta. So yes, I can write like this. Now, see from equation number 1, V1 square is equal to V1 dash square plus V2 dash square. So yes, I can replace this V1 dash square plus V2 dash square by V1 square. So here it is V1 square is equal to V1 square plus 2 V1 dash V2 dash cos theta. Clear about this? So yes, what happens if V1 square, if we take this side, then we will get 2 V1 dash V2 dash cos theta is equal to 0. Now 2 is not 0. V1 dash is also not 0. V1 dash not 0. V2 dash not 0. Then obviously cos theta is equal to 0. Cos theta is equal to 0. And yes, value of cos is 0 when angle between them is 90. When theta is equal to it is 90. Clear about this? So yes, this you have to prove. Okay, if you have one object having mass m moving with velocity v1 collides with object at rest elastically in 2 dimensions, and after collision the objects will move perpendicular to each other, means angle between them is 90. So yes, you have to remember this result. Clear about this? So yes, again it is one important question based on elastic cohesion in two dimension. Clear?